All right, guys, we have a video here of Math Antics. We love him. He's so good. I wish he could be my teacher.
Not better than you.
Oh, thank you.
Hi, welcome to Math Antics. In this video, we're going to learn about special kinds of polygons called quadrilaterals. Quadrilateral is just a fancy math word for a polygon that has exactly 4 sides and 4 angles, like this one. You should recognize this shape, of course. It's a square, and a square is a special kind of quadrilateral. It's a quadrilateral because it has 4 sides, and it's special because all 4 of those sides are exactly the same length, and all 4 of its angles are exactly the same size. In fact, they're all right angles. Notice also that a square is formed by 2 pairs of parallel sides. These 2 opposite sides are parallel, and these 2 opposite sides are parallel. We'll see why that's important in a few minutes. Okay, so squares are an important type of quadrilateral, but we're going to make some changes to the square to see what other types of quadrilaterals there are. The 2 things that we can change are the sides and the angles. Let's start by changing the sides. Let's stretch our square in one direction so that one pair of sides is now longer than the other pair. This is what we call a rectangle. A rectangle is a quadrilateral that still has 4 equal angles. Notice that when we stretch the square, the angles didn't change at all, but it does not have 4 equal sides. Again, notice that just like a square, a rectangle is made from 2 pairs of parallel sides. All right, so that's a rectangle, but going back to our square, what if instead of changing the sides, we had just changed the angles, like this? What we have now is called a rhombus. A rhombus is a quadrilateral that still has 4 equal sides, but it does not have 4 equal angles. And once again, just like the square and rectangle, the rhombus is made from 2 pairs of parallel sides. Okay, going back once more to our square. What if we try changing both the sides and the angles? Here's what we end up with, and we call it a parallelogram. It's called a parallelogram because even though its sides are not all equal and its angles are not all equal, it's still made from 2 pairs of parallel sides. Get it? Parallelogram. Now wait a second. If that's the definition of a parallelogram, a quadrilateral that's made from 2 pairs of parallel sides, then wouldn't all these other shapes be parallelograms too? Exactly. All of these shapes are parallelograms, just like they're all quadrilaterals. It's just that we have special names for them if their angles are all equal, a rectangle, or if their sides are all equal, a rhombus, or if both their sides and their angles are all equal, a square. Okay then, if all the quadrilaterals we've seen so far are examples of parallelograms, what's an example that's not a parallelogram? Well, to see one, let's start over with our square again. But this time, we're going to change it by moving just one of its vertices, like so. Now, one of the pairs of sides is still parallel, but the other is not. And a quadrilateral that has only one pair of parallel sides is called a trapezoid. Well, actually, this is where classifying quadrilaterals gets a little messy. And that's because this sort of shape is called a trapezoid in America, but it's called a trapezium in other countries, like the UK. Trapezoid, trapezium, trapezoid, trapezium. It's a trapezoid. At least they both start with the word trap, so it's not too confusing yet. Okay, so this quadrilateral is a trapezoid, or trapezium, because it has only one pair of parallel sides, and the other sides are not parallel. Here are a couple more examples of quadrilaterals that have only one set of parallel sides. All right then, what about quadrilaterals that have no parallel sides at all, like this one? These opposite sides are not parallel, and these opposite sides aren't parallel either. So what do we call this kind of polygon? Now here's the really confusing part. In America, this is sometimes called a trapezium. But isn't that what they call a quadrilateral with only one pair of parallel sides in the UK? Yep. Unfortunately, the same word is used to describe 2 different things in 2 different countries. trapezium, 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 trapezium. Well, at least they both like football. But to keep things clear at Math Antics, we're not going to call a quadrilateral that has no parallel sides a trapezium. We don't think it needs a special name. So we're just going to call it a quadrilateral. So to summarize, any polygon that has exactly 4 sides is called a quadrilateral. And if it has no parallel sides, we still just call it a quadrilateral. But if it has one and only one pair of parallel sides, we call it a trapezoid or a trapezium. Or if it has 2 pairs of parallel sides, we call it a parallelogram. And you've already seen that there's several types of parallelograms called rectangles, rhombuses, and squares. All right, so that's the basics of classifying quadrilaterals. And there's a few other special types of quadrilaterals, but we've learned the most important ones. But there is one more really important thing you need to know about quadrilaterals. You need to know that the sum of the angles of a quadrilateral is always 360 degrees. Now that's pretty obvious for a square or a rectangle. Those shapes have 4 right angles. And since we know that a right angle is 90 degrees, 4 times 90 gives us 360. But to see that it's also true for any quadrilateral, let's have a look at these 4 different examples. Watch what happens when we draw a line on each of them between a pair of opposite vertices. Each of the quadrilaterals got divided into 2 triangles. In the triangles video, we learned that the sum of the angles of a triangle is always 180 degrees. So it's not too hard to see that since the angles of a quadrilateral form 2 triangles, the sum of those angles would be 2 times 180 degrees, which is 360. Knowing that the angles of a quadrilateral add up to 360 degrees can help you solve problems like this one. For this quadrilateral, we're told what 3 of the angles are, but the 4th one is unknown. To find the unknown angle, all we have to do is add up the 3 angles that we do know, and then we subtract that from the total, which we now know is 360 degrees. So 100 plus 80 plus 60 equals 240. And then 360 minus 240 equals 120. So the unknown angle is 120 degrees. Let's look at one more unknown angle problem that's a little tricky. This problem asks us to find the unknown angle A in a parallelogram. But it looks like they only told us what one of the angles is, and the other 3 are unknown. So how can we possibly figure this one out? To solve this problem, we need to know an important fact about parallelograms. Because parallelograms are always made from pairs of parallel sides, that means they also form pairs of equal angles. It's the opposite angles that form these pairs. For example, in this parallelogram, the angles A and C are equal because they're on opposite corners, and the angles B and D are equal because they're on opposite corners. Now remember, this is only true for parallelograms. This won't work for things like trapezoids. So in our problem, even though we're only given the measure of one angle, since we know it's a parallelogram, that's all we need to figure out all the other angles. First of all, we know that angle B must also be 50 degrees because these opposite angles must be equal. Next, we know that the other 2 angles, A and C, must also be equal. So if we can figure out how many degrees are left over, or still unknown, we can just divide that amount equally between A and C. Well, the total of all the angles is 360. So if we subtract the angles that we know, 50 plus 50 equals 100, and 360 minus 100 equals 260, we know that A and C must each be half of 260 degrees, and 260 divided by 2 is 130, so angle A must be 130 degrees. Okay, that's all for this video. We've learned the basics of how to classify quadrilaterals, and we learned that a quadrilateral's angles add up to 360 degrees. Remember, getting good at math takes practice. So,
All right, right light on, please. Let's do some practice with with our quadrilaterals. My friends in my class and Mrs. Long's class, I have printed this for you, e-learners. You can follow along up here. All right, so looking at our first shape at the top. Zoom in here. All right, we are going to check off or put a little X or color in each box that applies to this shape. If something does not apply to this shape, you're going to leave it blank. Okay? Let's go through this first one all together. The first box says all sides are congruent, and already I'd heard somebody say, what does congruent mean? What does that word mean, congruent? Max? He thinks it means equal, but he's a little unsure as he's saying it. Mimi?
Like, they're all the same?
She says all the same. Ladies and gentlemen, look up on your iPad right now. That word congruent, what does that mean? And I'm thinking that word congruent, we should add it to our math notebook since we are a little bit stuck on it. So while you are looking it up, add it to your math notebook. Congruent. Bradley?
It says identical in form.
Identical. So I've heard 3 words that all have the same meaning essentially. Max said equal. Mimi said same. Bradley said identical. Are we on to something?
Yes. Yeah.
What does it mean then?
Parallel.
Does that mean parallel? Equal. Yeah, I like the word equal. All right, so for this shape, are the sides all congruent on this shape? Are they all equal in length? Yes, so color it in. Are opposite sides congruent? Well, if all the sides are congruent, would the opposite sides also be congruent? Yes, yeah. So opposite sides, if I'm looking at these two, are they congruent?
Yes.
And if I'm looking at these two, are they congruent? Yes. All angles are congruent. Okay, so let's compare this angle to this angle. Are they congruent? They look pretty similar. I think yes on those. Let's compare this angle to this angle. Do they look the same? No, this one looks more like an obtuse angle, doesn't it? And this one looks more like an acute angle. So no, they are not all congruent. What about opposite angles are congruent? Well, we were comparing that. That was the first one we compared, right? When I looked opposite, those looked congruent. Let's compare these two. Are they congruent to each other? Yes, these are both acute. These are both obtuse. So yes, opposite angles are congruent. Color that in. Does it have 4 right angles? No, meaning you can make like that little square, a perfect square in the corner? No. Does it have 1 pair of parallel sides? No, because, and I feel like this one's a little misguided here. Does it have 1 pair or does it have 2? Okay, and it has 2. Okay, so yes, it has 1 pair, but it actually has 1 more. So I feel like that's kind of a tricky wording on that one. Okay, so if you look below it, you have the option of 2 pairs. Does it have 2 pairs that are parallel? Yes. All right, now we need to be able to label it. What can I mark off for this quadrilateral? Is it a polygon? Yes. Is it a quadrilateral? Yes. Is it a parallelogram? Yes. Is it a rectangle? No. Is it a rhombus? Yes. Is it a square? No. And ladies and gentlemen, I had a couple people, for the most part you guys answered pretty good on our shapes right here. But I had a couple people saying yeses when they said should have been saying a no, and vice versa. Ladies and gentlemen, there's no tricks to this. You just have to memorize it. So those vocab words, these are our vocab words that we wrote down. go look at what they mean. If you're not sure if this would classify as a rectangle, go look up that definition of rectangle and see, does it meet that definition? Okay? There's no tricks on this, guys. It's just lots of memorizing. Memorizing means that you're going to need to study. Okay? All right, next one. We have a shape here. Right away, what kind of shape does it look like? Yeah, it looks like a rectangle. All right, so the first one. All sides are congruent. No. Are all sides the same size? No.
Only squares.
No. This side, look at this side. This is a long side, a long side. This side is a little bit shorter.
Yes.
Both of my sides right here are a little bit shorter. Are opposite sides congruent? Yes. So when I look at these two and compare them, they're the same. When I look at these two, they're the same. So yes, opposite sides are congruent. Mark it off. The next one, 4 right angles. Yes. If I looked at my angles in the corners, I could make 4 little squares. Right angles, perfect 90. Does it have 1 pair of parallel sides or 2 or possibly none? 2. Yep. These 2 are parallel, and then these 2 are parallel. All right. Let's see. What kind of shape are we working with here? Is it a polygon? Yes. And on our last one, I heard some yeses and nos too. Let's go back to that definition of polygon. It should be in your math notebook from our first lesson here. What is that definition of a polygon? Mason?
A 4-sided figure with opposite parallel.
A 4-sided figure with opposite sides parallel. Malia?
A plane figure with at least 3 straight sides or angles.
Say that again. You were good.
A plane figure with at least 3 straight sides.
A plane figure with at least 3 straight sides. Justice. Straight sides, a flat shape. Is this qualifying as that? Yes, it's a polygon. Good. Quadrilateral? Yes. Parallelogram.
No.
Are the opposite sides parallel?
Yeah.
Yes. Rectangle?
Yes.
Yes. Rhombus?
No.
No. Square?
No.
No. All right, on the bottom here, I want you to try this bottom one right now on your own. I want you to share your answers with somebody in your area, mask on. And if you guys do not agree on all of them, discuss. right, let's check. You should have marked off. Opposite sides are congruent. Opposite angles are congruent. 2 pairs of parallel sides. It's a polygon, a quadrilateral, and a parallelogram. All right, backside. All right, at the top here. Obviously, learning from kindergarten, what shape does that look like? A square. Yeah. All right, shh. On your own, I want you to mark what you can for that shape right there. In some ways, I find the square the most interesting. I'll tell you why.
Sarah, stop it. Oh, no. Hold on.
All right, on the square, you should have marked every box except 1 pair of parallel sides. Because it doesn't have 1 pair of parallel sides, it has 2 pairs of parallel sides. So you've marked every other box. So I think the square is interesting because it qualifies for almost every category that we go through. Yep, it is a polygon, it's a quadrilateral, it is all of those. Yep.
Rectangle?
It is a rectangle. I know that one's a little confusing. Well, that doesn't look like our typical rectangle. But ladies and gentlemen, yeah, you have to think about the actual written definition of a rectangle. When you're taught your shapes in kindergarten, you're taught that,
This looks like this.
yep, this looks like this, yes. You are taught that this is a square, this is a rectangle, and that this is a triangle. But now that you guys are farther advanced in your math skills, a square, did the square change at all? Can it change at all? No, it can be bigger, but all sides still have to be equal. Okay, so it can get bigger, but it can't change any other way. A rectangle, can it also look like this? Yes. And the true definition of a rectangle, a square qualifies as. Okay? So yes, this is still a rectangle also. Okay? A triangle, could it go like this? Yeah. Okay? Could it go
Yes.
like that?
Yes.
Yeah, it can go. The triangle can get mixed up in lots of different ways, okay? So it's kind of hard sometimes, I think, when you're taught, kindergarten first, maybe even a little bit of second, that they only are supposed to look like this. A rectangle can only look like this. A triangle can only look like this. But when we look at the true written definition, they don't have to look just like that, okay? So you gotta kind of think outside that box, okay? You guys are smarter than that now.
I get it.
All right, next one.
The boxes are square. Think outside the box.
All right, go ahead and do your next one. This one's interesting. One of your boxes changed. I'm not going to point it out to you. I want you to find it. One of your boxes changed in the wording. Actually, 2 boxes changed.
Yeah.
Oh, a couple more than that.
What?
3 boxes?
Yeah. Oh, yeah. 15. 44.
3. I think 3. And the boxes changed just because, again, it just kind of fit this shape. I want you to go ahead and discuss this one with somebody in your area. Mask on. Do the next two. The next two with somebody in your area. It can be 2 or 3 people just staying in your seat, mask on. Mimi, mask on. Discussing the last 2 shapes. Which boxes are you going to mark off? Everybody's working with somebody, guys. Seconds. All right, listening in 3, 2, and 1. Here we go. Show me a thumbs up or a thumbs down. We're looking right here at this shape. All sides are congruent. Thumbs up or thumbs down? Thumbs down meaning you don't mark it. It stays blank. Opposite sides are congruent. Thumbs up or thumbs down, everybody. Mrs. Long's class, come on. Non-parallel sides equal. All angles are congruent. Thumbs. Opposite angles of the base are congruent, meaning your base down here. So your opposite angles. 4 right angles. 4 right angles? You can make little squares in that corner? One pair of parallel sides. No more noises.
Yeah. Probably working on
Two pairs of parallel sides. Is it a polygon? Nice. Is it a quadrilateral?
Yeah.
Is it a parallelogram?
No.
Is it a rectangle?
No.
Rhombus.
No.
Isosceles trapezoid.
Yes.
What is that word? Who remembers what that word isosceles means? Brooklyn, I'm gonna let you try and redeem yourself.
Two sides are equal.
Two sides
something.
are equal to something.
Angles.
Two angles, she says. Is she correct? Two angles?
No, it's two something. I don't know what.
Two something. Help her out, guys. She's stuck on two something. I don't think that word something, I don't think we're going to find that in our math notebook or as a math vocab word, something. Mason,
Isosceles. Two isosceles.
he told me that the definition of isosceles is two isosceles. I don't think we can use the word in the definition. Raina, please give me some faith in our math skills. Help me out.
Two lengths are equal.
Two lengths, she says, are equal. Ben,
Isosceles is bigger than 90 degrees.
he says bigger than 90 degrees. Justice. She says two sides, two angles. Ladies and gentlemen, on your iPad, look it up. Isosceles trapezoid. What does that mean? Isosceles trapezoid. I think Raina is onto something. Take your hood down, please. Shh. Not using Siri. Type it in.
I can't even find it.
Isosceles trapezoid. Raina, follow up with us. Yep, go ahead.
Two sides are the same exact.
Two sides are the same exact length. Do we have that? Two sides? The exact length? Yes. Now, ladies and gentlemen, I will tell you that this labeled as a isosceles trapezoid, you're probably not going to see ever on a test or quiz, okay? They're going to call it just a trapezoid, okay? But I like having it on there, and we should have already known what that word isosceles meant because we just got done covering that from triangles. So we should have had that skill already that we could have applied our prior knowledge on that, okay? Is it a square?
No.
Thumbs. Okay, good. Malia, do you have a question?
Well, no. It's a statement about the isosceles.
Okay, go ahead.
Everybody said it was an isosceles trapezoid, but nobody knew what it meant.
Yeah, everybody said a thumbs up or they didn't know. All right, our last shape down here, right here. Thumbs up and thumbs down. Ready? All sides are congruent. Thumbs, no noises. Opposite sides are congruent. All angles are congruent. Opposite angles are congruent. I see some people waiting on me. Show me. Thumbs up, thumbs down. 4 right angles. 1 pair of parallel sides. Parallel. They do not have to be the same length to be parallel to each other. 2 pairs of parallel sides. Polygon.
Yeah.
Quadrilateral. Parallelogram. I have some friends waiting. Show me. Rectangle. Trapezoid.
I like that slow.
Trapezoid. I was just trying to mix it up. Did I get you guys? Was it good? So smooth. It is a trapezoid. Rhombus. Square. Please give me all thumbs down. Okay. All right, ladies and gentlemen, your math homework is an I know it math on quadrilaterals. There are 15 problems. If you get less than a 60, it's going to have you redo it. Now, while I have you on here, I also want to talk to you about language, okay? Because we don't have an actual language video. Because my friends here did a peer edit yesterday and got graded. My e-learners, you are going to do a self-edit on your food and energy paper. I want you to resubmit your paper so that you are going to get an A+. Even if you had just one thing to change, I still want you to resubmit me an A+ paper, okay? You also have a vocabulary on some words that are commonly confused, such as there, T-H-E-R-E, T-H-E-I-R, T-H-E-Y apostrophe R-E. We've discussed them. I'm pretty sure Mrs. Long talked to you about those too.
Yeah.
I think you guys have gone through some of those with her.